Hi everyone, I'm Brecht. I would normally say this looks like a great audience, but of course I can't see that, and I'm hoping that one day we can go back to in real life conferences. But let's do it as it is. So I'm going to talk about using Fauna as a data API for modern application. At the same time, I'm going to talk about combining the guarantees of relational databases with modern web and the power of NoSQL. So that is possible today, and that's what I'm going to talk about. We're going to debunk some myths. Now, because it's about databases, it might go a little bit technical. For the people who are not technical, I hope you do see the business value of what I'm about to explain. And if you at a certain moment get lost, don't worry. The key of this presentation is you actually don't have to worry about all these technical details because that's basically what Fauna provides. It's a service that takes away all this complexity. But to explain that, I don't want to just say it's like that. I want to explain why it takes away this complexity to actually give you more information. So let's get started. Who am I? I'm a developer, Brecht de Rooms, in my native language, and Databrecht at Twitter. I used to work as a researcher, as a consultant. I've worked for a great company called Kummel.io, which is actually the organizer of this data talks. And I'm, of course, super excited that I am allowed to talk here and reconnect with my former colleagues. At a certain moment, I started working for Fauna, and that's because I was following that technology for a long time, got super interested in the technology behind the database. And at a certain moment, I was convinced I really wanted to work for them and started working as a developer advocate for them. Some history on how Fauna actually emerged, which ideas were there, why did they decide to actually develop a new database? Because, another database, right? Basically, there were two people working at Twitter and working basically at scaling Twitter. They were early engineers there. And they decided pretty quickly that scaling databases is hard. It's really like the hardest problem you have when you start to scale your application. But they were hopeful and they were like, if you wait long enough, certain technologies will improve over time. I mean, databases will get better and we will get developer experience that we actually expect from a database. Few years later, years went by and they had to conclude that it's still hard. So at a certain moment, they decided to actually come together and start building their own database in which they will actually provide the developer experience that they would have expected when they were scaling applications or trying to scale applications. So what makes Fauna unique? What is the fingerprint of Fauna? Well, it's a combination of a lot of things. So first of all, it's an OLTP database that stands for online transaction processing. And it's basically the application that you typically get in your application stack. So you have your application, mobile or front end, you have your backend, and then your OLTP database. What it does is basically store all the things that your user does, all the transactions, basically all the changes it does, whether they book a ticket, whether they put something in their shopping basket, whether they actually buy a product. All these things are stored in the database. So basically, it's about your business logic. So if you have reasoning in your application, that will all depend on your OLTP database typically. On the other side of things, you have analytics, right? So how do you do analytics? Since we're talking at a data talks conference hosted by an analytics service, those are typically handled by OLAP databases. Although you can do some things in the same database, typically an OLAP database is much better at doing this. So once you actually scale, you typically separate these things. So we have on one side analytics, on the other side we have your business logic. On the analytics side, you typically have databases like ClickHouse, Druid, Rockset, Snowflake, or you could just use Kummel.io because they also have a data API where you can push towards, and they will actually handle the storage and the actual logic of your analytics query for you. And on the business logic side, you typically have databases like Postgres, MySQL, very traditional databases who have proven their value over time. They've proven that they're reliable. Well, Fauna sits in that space, and Fauna is actually a database that will serve to basically support your applications and support your business logic. If we put some more emphasis on that arrow, you see that the arrow goes one direction. It goes from business, from the OLTP database to the OLAP database. That's because your OLTP database is typically the heart of your application. It contains your business logic, but it's also the unique source of truth. So if that's the case, if everything, whether your data is correct, depends on that database, you typically want certain guarantees. These kind of guarantees are consistency, you want correctness. At the same time, you typically want relations, because if you have users, if you have products and you have shopping baskets, you want to bring those in relation and reason over those in relation. You, for example, don't want to book a flight for a plane, and that plane might already be booked. You don't want these kind of errors in your application, since then you have to go talk to the user and explain why his flight is actually not booked. Or yeah, you have to refund them. These kind of things are what we actually prevent by using a 100% ACID database. Fauna is also 100% ACID. That means things like uniqueness failures or things like the situation I just mentioned with the flight cannot happen. So in this case, two users are trying to sign up with the same name, and that's not allowed. In a distributed system, this might go wrong in many cases. This might seem evident, but it actually is not that evident once you start scaling. Other things like no failed ordering, which we often see in social media, that our messages actually jump around in order, and in this case, it creates it makes an application pretty hard to follow. So the person actually said first, "Thank you for severing our country," and he actually meant serving, but by switching these messages, it actually becomes extremely hard for the other users to understand. These are very simple cases. I already mentioned a more complex case, but it's really, really hard to understand when these things go wrong. So if you want to know more about these things, there are two links provided here. Fauna is also a relational database, and although it might seem evident in combination with 100% ACID, and as we will see, a distributed scaling database, it's really, really not evident. So these are actually traditional database properties, and I already mentioned it just 5 seconds ago. Does that mean that Fauna is a traditional database? Not really. Because if your database is the heart of your application, it will also be the database that will be hammered once you start to scale. It has to maintain the consistency of data. It has to verify correctness and things like that. And typically, if your application starts to scale, your database is the bottleneck or the pain point. So what we also want is we want a database that's fast, scalable, reliable, and therefore typically distributed. Now, people, when you talk about these two properties of databases or categories of properties, they typically think that you can't have both. So you would actually choose either consistency, ACID correctness, and relational, which would be more relational traditional databases like Postgres or MySQL, or it would be fast, scalable, reliable, distributed, typically Cassandra, DynamoDB, things like that. Why do we think we can't combine these things? Well, that's because the gap theorem has often been misinterpreted, and it might be misinterpretation, or it might actually also be clever marketing. Since the gap theorem says if a partition happens, so some shark bits a cable in the middle of the ocean and two servers can't communicate anymore, which means that your databases that are distributed, so there are two distributed database nodes that want to communicate, they can't communicate anymore. That means the state of one might be different than the state of second, which is not good. In this case, you actually have inconsistency, no, so not consistency. So what CAP says is if a partition happens, you either have to choose availability or consistency. Now, over time, we have started looking at the CAP theorem rather like this, without a if partition happened. Why is that? Well, because if you have a distributed database with multiple servers separated across the globe, in this case multi-region, then it becomes extremely hard to keep these databases consistent. Why? If so, imagine that someone writes to that specific node, then you actually have a lot of communication between those to make sure that everyone agrees that this is the new state. Now, these are called, these are specific algorithms like two-phase commit and things like that, that make, you need these algorithms to actually make sure that everything is consistent. And since we're bound by the speed of light, several hops back and forth, well, yeah, it takes quite a while, and nobody actually thought this was really feasible. Nobody wanted to pay that latency price. Now, that's why we just started saying, like, choose one, availability or consistency. And people or companies actually started marketing it like that. Now, if you look at a more complete theorem, which is called Backend, or I guess that's how you would pronounce it, I don't know. It also has an else branch, right? If the partition, if there's no partition problems, then you actually choose consistency over latency. So what you just mentioned is all these back and forths that increases the latency. Now, the thing is, nowadays there are algorithms that actually allow you to reduce this latency significantly. So Fauna is, for example, inspired by Kelvin, which, as we will see, will reduce the latency significantly. So that makes that it's actually possible to provide a distributed database at scale as well. So Fauna is, next to these traditional properties, also scalable. So it scales up in a way that is not like most scalable databases. So if you take a normal provisioned database, not a scalable database, then you typically have this. So you would have your usage, you would have plateau of provisioned infrastructure, and once you reach it, you basically have problems, right? So not this. And other more scalable approach, and this is how most of the scalable databases work, they will actually provision infrastructure for you again, then have an algorithm running behind the scenes that actually tries to determine, hey, I have to provision more infrastructure. Typically what happens if you suddenly scale up very fast, let's say you're featured on Product Hunt, just like Cumulio recently, kudos on that, by the way, then you might suddenly get a lot of traction, and the algorithm might not have foreseen that amount of increase, and you still have the same problem. Then at the moment it actually matters the most, your users can't reach your website. Afterwards, you are left with a lot of wasted resources until it actually scales down. Now, even if you don't pay directly for this, a company will deliver this model, has to incalculate this over provisioning, so it will be more expensive. So it's also not this. What Fauna does is, because it's a multi-tenant system, we can amortize this algorithm and actually provision as needed on a more global scale, which means that you get more something like this. So we also have a free tier, so you can get started for free, and after that, you basically scale as you pay as you scale. So you get seamless scaling. As mentioned, it's also distributed and it's even multi-region. So in Fauna, if you write some data to a specific location, it will be replicated to the whole world, which means that your clients are extremely close to their data, and which reduces the latency of your end user to actually get their data. As we mentioned before, it actually wasn't feasible before because of the algorithms. Due to Calvin, we can actually reduce these back and forths a lot, which makes it actually feasible for Fauna to be a distributed multi-region database. We will soon also have region selection, so you can actually select a region where you want to host your database, for in case you have specific region requirements or legal things to make sure that are in order. So as mentioned, this is inspired by Calvin, something I can't explain today, but if that really interests you, take a look at the link I've provided below. So these are all NoSQL database properties that are perfectly merged in one database with traditional properties. And then finally, but definitely not least, other features. As I mentioned, these engineers were wondering why are databases so hard to use. So one of the things that Fauna really focuses on is to provide an extremely good developer experience. Easy to use, easy to set up, and awesome features. So one of these things is developer experience. That will lead to user experience. Also, the way you also change how you architect applications, thanks to how the features Fauna provides a better user experience. And finally, there are quite some great capabilities. So let's look into these. What are these? And while we're looking into this, realize that Fauna is more than a database. It's actually becoming a backend as a service, rather. One of these things is zero setup. So you only have 3 steps to actually create a new database. Let's just do that. For example, here I just connect with my GitHub account. I actually already have a lot of databases. Since the database is just logical, you create a new one like this. But let's create a database within a database, since this is a demo, and I want to group these. Let's say data talks. I now have a database. And as I will say in a short while, Fauna also has GraphQL. So let's import the GraphQL schema. And let's just take a look at that GraphQL schema. So this is purely a schema with a few queries and mutations, which are not defined how they should be implemented yet. If we import that schema, we immediately get a GraphQL endpoint that we can actually use. So if I would throw in a query in that playground, we actually created some data, which is now visible here, and it linked it automatically with the project I created. So as you can see, that's the same as this, but then in documents, what I expressed as GraphQL. So as mentioned, GraphQL. So we have 2 query languages. We have our main Fauna query language, which is extremely powerful, and that query language was actually perfect to provide GraphQL. So we provide GraphQL as well out of the box, as you saw, and everything we provide with GraphQL has the same guarantees as FQL. So that means the same consistency guarantees and things like that, and the scalability aspects and things like that. As you just saw, Fauna is actually a document database, but although many document databases would not provide relations, Fauna does provide relations. So documents look like this. So you just have plain JSON, which is the language of the web, of course. And within this JSON, you have specific Fauna-specific types, which in this case are references to other documents. So we do have relations here, and we can get transactional. We can do queries over those relations in a transactional way. We also have powerful indexing, which for a distributed scalable database is not evident. Most of the time you have to know in advance how you're going to query. In Fauna, you just create as many indexes as you want afterwards or before, as you want. And you can have composite indexes without a problem, and can even go very, very deep if you want. Can have multiple terms in the same index. Fauna is temporal. That means that all the changes are tracked over time, which is a pretty cool feature. But even cooler is that you can query at a specific timestamp. You would be able to execute a specific query at the time and do it as if the database was still at the time that it was then and in the same state. At the same time, the temporal model allows us to actually get changes over time, so a kind of stream of events. So if we do a specific query, temporal query, we could actually get the initial update and then get all the updates, or get all updates after a specific update. Besides that, the temporal model is perfect for allowing streaming, which is currently in preview. That means that we can also push data towards others, and that will probably be super interesting for data integration partners, which there are a few here today as well, if I'm not mistaken. So you would actually be able to push data to your UI for live updates, or let's say push data towards Cumuli to actually add it to the analytics storage. As you see, I actually put an arrow directly to the front end here. So that might be a little strange at first, but that's something we call ClientServerless. I said that Fauna is more backend as a service. We actually provide features. First of all, Fauna is communicating over HTTP and has certain security features that allow you to actually contact it directly from the front end. That might eliminate the hop. You might not need a backend for some cases, so that's less for you to actually deploy and scale. And if you want to know more about that, the client serverless aspect actually means that in the future, we will see the client more and more as the center of everything. Does that mean there is no backend anymore? No, these backends are more integrated into services, and if you need them, they're still there, but in the form of serverless. And Fauna is also serverless ready because it's HTTP. So we don't have a fixed number of connections. You can easily access it from Netlify, Cloudflare Workers, AWS Lambda, without actually worrying about these connection limits. That's what Fauna is, and this is the signature of Fauna. So it's all these things together, which makes for a very, very great database with great developer experience and allows you to move fast and deliver a great user experience as well. If you want, you can try Fauna for free. Join our community Slack or community forum if you have questions. If you have questions that you want me to answer right now, feel free to shoot.